Okay, let's see. Trevor Bello, are you here? Trevor, what company are you writing your little report on? Microsoft. What's interesting about Microsoft? Or what did you find interesting about it? What did you find interesting about Microsoft? Yeah. Is it the biggest? I believe it is. Okay, number one. Okay. Okay. Salim Faruqi. Are you here? Salman, S-A-L-M-N, Salman Faruqi. Not here. Okay, Madeline Jalifi. What are you writing on?
Oracle.
What did you find interesting about Oracle?
I'm talking about Larry Ellison.
No. Who's Larry Ellison?
The CEO of Oracle.
Right. What's interesting about Larry?
Well, at one point he was richer than Bill Gates.
He was what?
Richer than Bill Gates. But
Oh.
I don't think he is anymore. But at one point he was.
Really? Okay. So Gina Kim. Yeah. What are you writing on? Dell? Okay. What did you find interesting about Dell?
The founder, Michael Dell, was only 19 years old and he started building computers at his 15
Great. Okay, Jeffrey Lee. Jeffrey? He's on his way to class?
He parks his car, it's
Oh dear.
but he's always good.
Okay, well, I'll see if he comes in. Mingi Lin. What are you writing on? What? What's interesting about BMC? I can't hear you. The BMC does basic IT design. I mean, you're writing something about BMC that's particularly interesting. What is it? You haven't done your research? Mm. Okay, Sumya Samuel. I talked about intellectual property rights last time. What's the difference in a patent and a copyright? For what? Right. And what about a copyright? That's right. Very good. Okay. Is April? Are you here? April, send me some email. Kim Fan. Kim, are you here? Kim, what do we mean by DRM? In respect to intellectual properties, digital rights management. Okay, what is that? Well, basically, digital rights management is itself technology, right? It's a program, or it's something that's available technically to protect property rights. Okay, it's something that keeps software from being copied too much. Okay, and stuff like that. By the way, you know, you're signed up here for this is a computer science course, and you know the computer science department has license with Microsoft, and so we have all of the Microsoft software, that is system software. It's available up on the 5th floor. You can go and request it. So if you are interested in doing any kind of software work, you know, all you have to do is go up to the 5th floor of this building, and there's I think room 547. Anyway, it's the room or between the elevators, you know, and there's a system person there, and they can give you copies to various software from Microsoft system software, such as Visual Studio, and I was talking about Visual Studio last time. Okay, that's very good. Tim? Okay. April's not here. Connie, 2? Connie, what is meant by DMCA? Right, and what is that? It was a copyright law, exactly, in the year 2000. So that's right. It was in the year 2000 again. Okay, so last time I was talking about software, and I was talking about software engineering, acquiring software, software license. So I mentioned that software engineering is the, I guess, the engineering discipline, or at least we think of it in computer science as an engineering discipline. And there are these steps that you go through in developing software. We're particularly thinking about large-scale software, enterprise-level software. So you're writing the software that run businesses. I talked about computer programming. I mentioned some programming languages last time. So Dan Vu, what programming languages did I talk about? HTML. What is HTML? What does that stand for? Do you know what that stands for? HTML? It stands for Hypertext Markup Language. What it means is it's the notion of hypertext is that it's just text, like stuff that you read, but certain parts of this text are in blue, and you can click on certain parts of this text and it takes you to another page that has to do with that particular part of the text. So basically there are these web pages that are joined together, okay, by these links, and these links are called text. it's a markup language. What is a markup language? Well, a markup language is any sort of language that's sort of like editorial comments. You can submit a paper to an editor, and the editor has these marks they put on, the paper, editorial marks, and these are used for correcting the paper. Also, they were used mainly for typesetting the paper. So any sort of system of marks that explain how a text document is really to be displayed is a markup language. And so the hypertext markup language is the main language by which one describes web pages. So if you want to have a web page on the internet, you just have a text document, which is this web page, okay? And this text document has all these extra marks in it that says when you display this text on the web, it looks a certain way. There's special marks for headers and second level headings, okay? There are marks, for different colors, different fonts, and for inserting pictures and things like that. Okay. So let's see. What was another language I talked about? Chastity Zuniga. Chastity, are you here? What other language did I talk about besides? I really didn't talk about HTML very much. What did I talk about? Or name a computer language. You don't remember? Okay. Okay, Grace Agbula. Grace, name a computer language. Fortran, that's good. What's Fortran? Stands for Formula Translation, that's right. And it's the oldest and the first successful commercial high-level language, right? Very old language, yeah. Been through a lot. Fortran's been through a lot over the years. So, computer programming is the process of creating software through the use of logic, algorithms, and programming languages, okay? So Microsoft Visual Studio is a popular integrated development environment. And basically you bring up Microsoft Visual Studio if you want to write a program, and it has these various windows on it, and these various windows you can use to develop your program. And it has facilities in it for putting in what are called widgets. And so in developing your program, you normally have to think about bringing up a window or more than one window on the screen. And then in this window you'll have various things there, okay? And so the things that you'll have are, among other things, widgets, okay? So, so what's a widget? Well, widgets are things like just right here, these little boxes, okay? Here. And so you can click on, there are things you can click on, okay? So for instance, if I click on this, see, this is a push button widget, okay? if I push on it, then you know, the let me get highlight in that color, okay? And if I push on this, okay, then it erases everything, okay? So these are all push button widgets, okay? It also has basically a word processing part of it, okay? So you can actually type in your computer code. So programming languages. Programming languages provide a set of symbols, key terms, commands, rules, okay, used to write a computer code, okay. So here you can't see it because it's not big enough, but this right here is a part of a C program. A compiler takes the source code and produces object code with an executable file and support files as output. Here's the source code here that you wrote. Here's the compiler, and it outputs the thing that runs on the computer. An application programming interface is a set of programming tools to provide access to an operating system. Okay, so we acquire software. You can acquire it off the shelf, okay? Or you can get somebody to build you the software. Okay. Or basically you can run the software on the cloud. That means on the internet somewhere. Off-the-shelf software is software that's mass-produced, made available through online outlets and retail stores. Custom design software is software to create a unique need, okay? Thousands of online businesses deliver software-based services like Google, Facebook, okay? Hulu, Twitter, eBay. Cloud computing, talked about that over the internet. Okay, so software licenses, okay. So a software license defines permissions, rights, and restrictions assigned to the person who purchases it, okay. So there's freeware, there's open source software, and something called the Creative Commons license. So freeware is software that is made available to the public for free. As you go, you know, traveling around the internet, you'll see various you know, software that you find you know, is nice to have. You can download this software and it doesn't cost you anything. So for instance, here's examples here: Thunderbird, Pigeon, okay. Probably the Adobe Reader is the most famous example of freeware. So usually you get a new computer and set it up. One of the first things you do is download the Adobe Reader. Yeah. There's something called OpenOffice. What's OpenOffice? You can download OpenOffice free of charge. Sure. What is OpenOffice? Anybody know? Does anybody use OpenOffice? Well, what's Microsoft Office? Well, let's you go to Cougar Byte and you can buy Microsoft Office pretty cheap. What does it cost to buy Microsoft Office at Cougar Byte? It was $14, $15, right? Really, really cheap. Okay. And what all does that include? Microsoft Office. Well, it includes several main applications of a computer that are used in business offices, right? It has Microsoft Word, okay, for creating documents, okay? And that's what you're using, I suppose, you know, for this first assignment. Okay? Microsoft Excel for spreadsheets, and we're going to be doing spreadsheets starting next week. It includes a PowerPoint, Microsoft PowerPoint. It includes Microsoft Access, which is a database software, and other things. There's actually a number of different, there's something for publishing things, okay, and other things. OpenOffice is free version of the same stuff. You can download OpenOffice, okay. It has a word processor, it has a spreadsheet, it has a presentation, okay, and very similar, okay, to Microsoft, except you don't have to pay anything for it. Freeware is different from open source software. Freeware, they give you the program, but they don't give you the source code to the program. Basically, you get the object code or the executable code, and that's usually all you want because you just are going to use it on your computer. You're executing, but it doesn't give you the source the source code for that. If you have the source code, you see, you can actually modify that. You can extend it, okay, and change it. And these people that give you this free software don't necessarily want you to do that. But there are some people that actually give you the source code as well, and called open source software. Open source software is distributed typically for free with the source code so it can be studied, changed, improved by its user. What is this right here? What is this strange animal? Anybody have any idea what that is? It's a GNU. And this GNU is the logo for an organization called the Free Software Foundation. And the Free Software Foundation is kind of an interesting organization. Here's a strange looking character, don't you think? His name is Richard Stallman, okay? And this guy is in charge of the Free Software Foundation. And he comes out and gives talks and stuff like that. Okay? Anyway, Stallman's idea and the idea of the Free Software Foundation is software should be free. People shouldn't charge for software. People ought to just write software and give it to everybody else. Okay, it's a very simple concept there, and he will actually go around and give you his side of that. Okay, if you're interested. So, do you think software should be free? Well, here's some examples of free software, and not only free software, but open source software here. Okay, there's an operating system. Okay, called Linux. Have anyone ever heard of Linux? Nah. Well, let's talk a little bit about operating systems, okay? What operating systems are you familiar with? Well, you're familiar with Microsoft's operating system, okay? It's called Windows in general. But there's different brands of Windows, right? Different versions of the Windows operating system. What are some of the versions of Windows that you know about? Well, there was a Windows 98. Then there was a Windows XMP. And then there was a Windows Vista. And then there's a Windows 7. Yeah. And that's not nearly all of the versions of Windows. Okay? The latest version of Windows, and the one that if you buy a computer right now and it has the Microsoft operating system on it, it'll be Windows 7. That's the latest one. Okay? Before that was Windows Vista. Before that was XMP. Okay? I believe, if I'm not mistaken, the computers that you're working on in this lab still have Windows XMP as the operating system. And so, of course, Windows 98 is now obsolete, and I guess there won't be around much again. But as Microsoft went from Windows 98 to Windows XMP to Windows Vista to Windows 7, these are all supposed to be improvements on the operating system. Now, there was a big line drawn here between all of the versions of the Windows operating system up to XMP and then after. And Vista and 7 are called 64-bit operating systems. And before that, these are 32-bit operating systems. And if you go back really far enough, there are 16-bit operating systems. Okay? This has to do with computer architecture, and it has to do with how much data is shipped back and forth from one part of the computer to another along the buses. Okay, and computers used to ship data back and forth 1 byte at a time. That is 8 bits. And when you enter data into a computer, it entered data 8 bits at a time. Then, as computers got better, they started doing all of the I/O and all of the bus shipments internally 16 bits at a time. Okay. Then they went to 32 bits. Okay, and now Most processors, the newer processors, are all 64 bits. Now, actually, there's 32-bit versions of this stuff, and but 64-bit is the latest. Correspondingly, there's like in the browsers, like Internet Explorer, there are 32-bit versions of Internet Explorer and 64 bits versions of Internet Explorer. So if you get a new computer, you know, you may have 64-bit Internet Explorer, or you may have both. So these are the operating systems we know about. Also, if you have a Mac, it's the Mac OS, right? Well, if we go back a long time ago, say to the 1960s, operating systems were much more primitive. And there was a lot of work in designing operating systems. And there was this big project at MIT called Multics. And this project was really a novel thing, okay? This was the 1960s, okay? And the idea was you take this computer and you hook it up to a teletype machine. And a person can sit at this teletype machine. It's kind of like a typewriter, you know, with some electronics in it to connect it to the telephone wires. Okay? And that you can send data directly from these teletype machines back and forth to the computer. And furthermore, in this MIT project, the idea was to put many teletypes around. Up until this time, computers had operated on IBM cards, they were called. So these punched cards, and to put data into a computer, you know, you had to basically type your data into this punch card and read these punch cards with a punch card reader. To have the idea of putting these teletypes basically around Cambridge, Massachusetts, so you see, so the researchers could actually have this teletype machine in their home. And then they would have a transceiver, they'd have your telephone, okay? And the telephone, you could call the computer, okay? Hang the telephone up, okay? And so that it basically, you know, it was like a fax, okay? And then basically you could have interaction between this teletype and this computer. And this operating system project was called Multics because it basically handled multiple people all at one time. And so that this person over here was interfacing with the computer on his teletype at the same time these other people were. But none of these people, you know, knew anything about one another. It appeared to these individual people they had the computer all to themselves. But in fact, the computer was time sharing. The operating system was time sharing this computer. So basically, if you looked at a timeline, then here user 1, you know, would be on the computer for some period of time, and then the computer would go over and let user 2 have it. The computer could actually only run one person at a time, okay? And so it kind of is round robin. That is, it's basically hooked up with user 1 for a little while, then user 2, then user 3. But it did this on a very small scale. That is, we're talking about a millisecond, okay? So it did user 1 for a millisecond, user 2 for a millisecond, user 3 for a millisecond, went back to user 1. So what that meant was user 1's program would be running on this computer for this short amount of time, this millisecond. Then the operating system had to stop it in midstream. It had to remember where it was, what the state of the program was, and sort of store the state of this program, exactly which instruction it was on, exactly the values of everything. Then it would go to a different part of memory and work on user number 2's program, and then user number 3's, and then when it finally got back down to user number 1, it would restore what was happening with user number 1, as though nothing had transpired. You ever seen these movies where they have some sort of magic clock or watch or something, and the guy clicks on it and it freezes everybody? You ever seen a movie like that? There's been a lot of movies like that, right? Yeah, it's like everybody freezes it, except this one person, right? And then you click again, and people, you know, start acting it like nothing happened, right? Well, it's kind of like that, you know. They click the thing. User number 1 kind of freezes, okay, and user number 2 click again, okay, and so it's time sharing, okay. So that was the beginning of the notion, you know, that you can do lots of things at the same time on a computer. You know, we still do that. So let's bring up the task manager. If you hit alternate control delete all at the same time, you can bring up the task manager. And the task manager basically will show you all the things that are running on your computer at the same time. So we can click on the applications tab, okay? And that shows me here that my computer is running 2 applications right now. It's running this classroom presenter set of slides, and it's also still got the Free Software Foundation Google search up, okay? But then if I click on the processes tab, there are 66 processes running on this computer at the same time. So I think the computer is doing 2 things. It's actually running 66 different programs simultaneously. And what are these programs anyway? You know, well, there's a lot of stuff going on here, okay? There's the Google Toolbar program, okay? It's suspended right now, okay? All these things are suspended, okay? There's the iTunes Helper program. There's the Mac Tray program, you know. There's all these, Dropbox, yeah. And this right here, the username, this says whose program it is, okay? Like in Multics, you know, it had these different users, see. Of course, I'm the only real user here. If I go down here and say show processes from all users, if I click on that, then it shows me who these other users are. Well, they're not really people users, this is the system, okay? As the operating system is running this process, this process, this process, and this process. Some local service is running this. I'm running this camcorder, but I'm recording the thing. The system is running this, okay, and all that. There's also some services being run. Okay. Here's performance here. Shows me how my computer is performing. This tells me how much my CPU is being used. So here there's two graphs here. That's because this computer that I'm using has two CPUs in it. And so it's showing you how much each one of these CPUs is being used, yeah? And how much memory is being used, yeah? How much of the internet I'm using, right? How much network traffic there is, almost nothing. Okay. Who the real users are, I'm just the only user. See? So anyway, this idea of multics, okay, was first invented by this multics project back at MIT. Well, at the same time that this multics process program was going on, at Bell Labs, they built a little computer, and some people at Bell Labs built a little operating system that was only for one person, and they called this operating system Unix. And this Unix operating system was sort of it was I don't know, it was kind of a clever thing. See, this big project that was going on at MIT was multics. Multics meant here's an operating system that'll, for many people, okay, and many users simultaneously, okay. And so they built this little operating system, okay, only for one person, and basically did the basic system work that was needed only for one person. They called it Unix. Well, later this Unix operating system was modified, okay, for newer machines when the PC came out. And there was a guy over in Finland called Linus Torvalds, okay, and he came up with a version of Unix called Linux. His name was Linus Torvalds, okay. And so that's Linux. And so this Free Software Foundation basically took his version of this operating system, okay, and made it available to everybody. So basically you can download this Linux operating system, okay, there's many versions of it now, okay, and you have your own operating system, okay. So if you don't like Bill Gates' operating system, okay, or you don't like somebody else's operating system, you can, you know, download this Linux operating system, and you have the source code, and you can modify it and do whatever you want to with it. Open Office, I've already mentioned, okay. Database software, there's MySQL. We'll talk about SQL later in this course when we get to database systems. SQL stands for the structured query language. Firefox is a free browser. Okay. The Creative Commons license is designed to allow the creators of intellectual property to specify the terms of the license in order to grant certain freedoms to users, while providing the owner with some control of the property. Usually the Creative Commons license is like this. Let's say you're an artist, and you are doing this art that you make available on the internet, and people can just look at your artwork and download it free of charge. But then it'll say on his web page, you know, if you're good-hearted, you know, you might want to send the author $5 or a small contribution, okay, for his work. Artists who use Creative Commons license like it because it allows them to earn a living from the distribution of their works while encouraging others to build on their creativity. Has anybody ever bought anything like that through the internet? It's something free and anything as well. If you feel like it, send me $5. Nobody's ever done that, huh? Well, maybe it's not. Maybe it won't make you a multimillionaire. Okay, system software. Any software that coordinates the activities of the hardware and assists the computer in functionality is system software. So the boot process, okay, is system software. So when you first turn your computer on, it's set to run the boot process. The boot process is installed in the computer on what's called firmware, and basically gets it ready to go. The boot process ends by turning control. The boot process usually reads in the first part of the operating system and then turns control over to the operating system. So the operating system is system software. The user interface is system software. File management. Linux is an example of an operating system. Yeah, these are all operating systems over here. Okay, so the boot process, also known as booting up, or bootstrapping, is a sequence of instructions in the BIOS. What does BIOS mean? That stands for the basic input-output system. It's a sequence of instructions that are executed when a computer is powered on to check the system, load the operating system. The boot process instructions that are part of the BIOS is burned into memory, so it's always ready for the processor to execute. So an operating system is a set of computer programs that runs or controls the computer hardware and acts as an interface with both application programmers and users. Now, why do we need an operating system anyway? Why don't we just not have one, you know, just run your program? So here's your computer, and this computer has peripherals, okay, resources. Okay. Let's say it's got a disk, and maybe another disk. Maybe it's got a connection to the internet. It's got a screen. Well, the reason you have to have an operating system is because normal users don't like to have to mess with these disks and screens and various things that hook up to the computer at a low level. Okay. But particularly if you're going to have multi-processing, if you're going to have many processes run at the same time, And it's critical on computers nowadays that you have many processes running at the same time. You don't want these individual processes to do things to the disk or to do things to the screen, okay? It would be like too many cooks in the kitchen, right? You don't want a process to change your screen on you, okay? I mean, you want this all done in a very controlled way. So basically, the operating system sort of owns all these resources, and then these processes have to use these resources. But basically, when a process wants to use one of these resources, it tells the operating system what it wants to do, and then the operating system does it for the process. Okay? And that way, you know, it's a more controlled thing. So your disk doesn't become corrupted. Okay, I mean, if you let the individual users, you know, have access to all these resources, you know, uncontrolled, you know, your disk would be corrupted, you know, right away. Other than, you know, your machine would just sort of die on you, and you wouldn't even know what happened. So a user interface, a UI, allows one or more people to have access to and command of a computer. Microsoft claims that its Windows Phone 7 series will change the mobile phone industry. This is this slide's a little bit old. They recently just redid that, by the way. File management refers to the physical and logical storage system and practices provided for managing data on a computer. So if you have a disk file, so here's the disk file, there's all the data on the disk file. Then these different files are stored on this, you know. So you know, user 1, you know, stores something on disk, and then user 2 stores something on disk, and then user 3 stores something on disk, right? And all these files get stored out on disk, okay? And then let's say some user deletes a file. So let's say user 1 comes in, user comes in and deletes this file. Then you see there's kind of a hole on the disk. I mean, there's stuff up here, and there's stuff down here. Okay, this stuff is gone. Okay, and so now somebody comes along and writes another file. Well, you know, you do know, by the way, when you delete something on a computer, it's not really deleted. It's not gone. It's just marked as being gone, okay? The operating system makes a notation, okay? This part right here has been deleted, but it doesn't actually go and erase it. So, you know, there's been a lot of criminals caught in court, you know, they thought they deleted stuff off their computer, and it's not gone at all. I've been an expert witness, you know, on cases, criminal cases, you know, where people, you know, thought they had deleted things on a computer, and they haven't. If you really want to delete something, what do you have to do? Let's say you want to be a criminal. You want to delete this stuff you have. What? Well, you can do that. I've actually had I've been on cases where people did that. They took the disk out and wham, like that. Okay. You can still get stuff. Maybe. Okay. Maybe not all. There are actually companies who will take a disk that have been, you know, done that way, and take them and straighten them out, and recover what they can off of them. Okay. On a disk that's been done like that, you usually can't recover all of it, but you can usually recover some of it. And you'd be surprised, how a disk can be hammered up and still, do that. What if you don't want to know? What if you don't want people to know what you've been doing on the internet? Okay? I mean, you give this computer, to a computer expert, your computer. You can tell people, what you've been doing on the internet, right? And what pages you've looked at. Okay. How do you keep them from doing that? Anyone know? Yeah. How do you get rid of all that? Yeah. Yeah. You go over to Tools, right? And you click on Tools, right? And here's Clear Recent History right here. Here's Options. Okay. This is Firefox here. You probably more often use Internet Explorer. So you go up here to Tools. You go down to Internet Options, okay? And then here's your delete, okay? Browsing history, delete temporary file, history, cookies, saved passwords, okay? Delete browsing, and so click on delete, okay? And then you have your option of what things you want to delete, okay? Preserve your favorite website data, okay? Keeps cookies and temporary from your favorite websites. Well, if you don't want to do that, okay, you just click that, okay? If you want to delete temporary internet files, you probably do, because when you're on the internet, basically it keeps a lot of stuff on temporary files, okay? And it doesn't get rid of those necessarily. Okay? You want to click that. Cookies, okay, files stored on your computer by websites to save preferences, okay, such as login information, okay? So if you want to get rid of your cookies, okay, if you want to keep cookies, you can do this, okay? This will get rid of your temporary internet files for cookies, history, your download history. Okay? Form data, this is where you have filled out a form. Like you bought something somewhere and you fill out a form. And next time you go to that site, it's got that form saved for you. Passwords, okay. ActiveX filtering and tracking. Okay, so you pick what it is you want to get rid of. What's a cookie anyway? What's a cookie? So when you bring up somebody's web page, like let's say you bring up HP's web page, and let's say you buy something, okay? Then HP, whoever it is, web page you brought up, they'll leave a cookie on your computer, and this cookie is just a file which says, when you logged on to them, and what you did, okay, and what you're interested in, okay? The next time you go to that same company and bring them up, first thing they'll do is look to see if they've left a cookie on your computer. If they've left a cookie, then they say, well, when's the last time this person logged on? What did this person do? What did this person buy? What's this person interested in? Okay? And that helps them, okay, service you, So the cookies take up a lot of room. No, they don't. They're fairly small, and they're pretty much harmless, okay? except it's probably a good idea to get rid of them every now and then because they do manage this, you know. I mean, if you're on the internet, you know, they're saving all this stuff, okay? And the more you use it, the more stuff gets saved, okay? These temporary files, okay? These cookies, and all this other stuff, okay? And it's good just to get rid of it every now and then, okay? So you just hit delete, and it deletes your browsing history, okay? It deletes all of your temporary internet files, okay? And then that stuff is all gone.
Is that really even like the other stuff on the computer though? It's saved somewhere and just marks it for deletion?
That's right. So it makes that all that space on the disk, okay, it makes available, okay? So anytime you say delete, okay, so it's gone, okay? That is, it's marked as being gone, okay? So like here, if this is marked now if somebody else comes along and then writes another file, the operating system knows that this here is gone, and so the operating system then can use it again. And so your new file will get written on top of this, okay? And maybe it's also written down here, so that your file isn't necessarily all together in one place in the disk, okay? And part of it was put up here because this was now free, but it was too long for that little hole, so it's put some more down here. So actually, after a period of time, your disk gets sort of striped with stuff, okay? And so one file, you know, on your disk, maybe a little bit of it here, a little bit of it down here, more of it down here. I mean, your file can just be, parts of it can be all over. It's called fragmented, okay? And so sometime, you know, this can be a problem if your disk gets too fragmented, okay? It slows down your computer. So how do you defrag? You use the operating system to defrag, right? You can just click down here, okay? And you can go to Programs, and you go up here to your accessories, okay? And then there'll be something called System Tools. And there's one called Disk Defragmenter. And it says which disk is it you would like to defrag. I've got two of them here, a C disk and a D disk. We'll click on that, and I'll say, you can say analyze the disk. So schedule defragmentation. Defragmentation is turned on at 1 a.m. every Wednesday. Okay? Only disks that can be defragmented are shown. Okay? So anyway, you might want to do that every now and then. So anyway, handling your disk is something that's done by the operating system. So file management refers to the physical and logical storage system that practices provide for managing data on a disk. Operating systems provide tools for managing files. Microsoft Windows runs on roughly 90% of all personal computers. Microsoft Windows is the most popular operating system for personal computers. These slides that I'm showing in this class accompany this textbook. They're 2 or 3 years old. That might not be 90% anymore. Apple has come up in the world, and they still are small compared to Microsoft, but 90% might be optimistic now. I would say it's probably gone down a little bit from that. Mac OS. Many Mac users also use Microsoft Office on Mac, okay? The native operating system for Apple PCs. This Mac OS is basically Linux. Or Unix, I should say. It's basically based on the old Bell Lab open system Unix, okay? And it's very similar, okay, to Unix. Linux, free open source operating system. People can not only get copies of Linux free of charge or low cost, but they also develop their own stuff. Virtual machine software, also referred as virtualization software, allows one operating system to run on top of another by creating a virtual machine on which the guest operating system can run. That was invented by IBM many years ago. VM. Mobile operating systems, lightweight operating systems for mobile devices. Proprietary operating systems are owned and kept private by the handset manufacturer. Proprietary. Open operating systems. Industrial operating systems control large network systems. The Unix operating system is used a lot on these servers. Embedded operating systems. So these are operating systems that are embedded in a different device. Okay, they're just part of the device. Utility software like defragmentation, backups. Okay. Finally, there's application software like word processing, spreadsheets, presentation, database. Okay. Productivity software. Productivity software is any software designed to help individuals be more productive. Word processing, spreadsheets, databases, software. Rich internet application. An increasing amount of software is available online for free. A rich internet application. Well, software has to be installed. Okay. So I'm out of time, and but basically that's all I have to say about the software thing. So next week I'm going to start talking about spreadsheets, and I'm going to hand out your second assignment. It has to do with doing a spreadsheet, and so that's what I'll be talking about next time. I'll be doing some examples, okay, of spreadsheets. Yes? Am I going to talk about what? Oh yeah, next week we'll have our first exam Thursday of next week, okay? Thursday of next week. Yeah, I'll talk about that.
I was wondering, on the paper, do you mind if we use Wikipedia?
No, I don't mind, but what do you mean use it?
Well, for like research.
Well, you don't cut and paste.
No, like this,
finding information.
Oh no, that's good.
Okay.
I want you to do that.
All right, thank you.